Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at EtherChannel Operation. We'll be discussing link aggregation, EtherChannel, advantages of EtherChannel, implementation restrictions, AutoNegotiation protocols, PAgP operation, PAgP mode settings, and finally, we're going to look at LACP operations. This episode is part of my series on switching, routing, and wireless essentials. I'm Kevin here at KevTechify. Let's get this adventure started. There are situations, there are places out there where you're going to need more bandwidth. You're going to need redundancy to make sure that your network doesn't go down. And how we can do this is something we call link aggregation. Link aggregation provides us the redundancy, but the problem with having these multiple links, these redundant links, is our spanning tree protocol. They're going to block those links. Remember how spanning trees stops those loops on a layer 2 connection? Well, when we start looking at this, we're going to have these multiple links, multiple connections, multiple paths. They're going to be blocked by spanning tree protocol, especially when we start using more than one physical port, one physical connection. And so what we need these redundant links not to be blocked by our spanning tree protocol. This is something called EtherChannel. What EtherChannel does is it takes a number of physical ports. Those ports you can see on the front of your switch. We plug some cables into that, and then we logically group them together in one logical connection. Because they're one logical connection, STP sees it as one connection and doesn't block all those multiple connections together. Now, when we get all these multiple channels together, this gives us fault tolerance, because if one of those connections goes down, the other ones will still be up. Load sharing, it goes between them. It balances out the load between all of those connections. Hopefully you won't have any bottlenecks then. We have increased bandwidth, because if you have 4 1 gig connections, that gives you a 4 gig logical connection. You can get more bandwidth through there. And then we have that redundancy again, where if one goes down, the other 3 will still be there. And once again, we do that by combining our physical links. EtherChannel was a technology that was developed by Cisco. It enables the switch to have multiple layer 2 connections look like one logical connection. It's a virtual interface when they do it, and it's called a port channel. So when we combine all those physical connections together, we create something that's called a port channel. We bundle them together, and if you look at the diagram here, we have a switch in the center here on the bottom, and then in the upper right, upper left, we have some other switches, but we have 2 connections going between them. And a lot of times when you see these multiple connections going through here, you're going to see a circle covering it. This is a purple circle here. That's showing that these 2 physical connections between this is forming one logical connection. That logical connection then, STP doesn't see a loop there, it just sees one logical connection, so it does not block that port. There are several advantages to EtherChannel. One of the first ones is you configure that EtherChannel in one place. You do all the configuration on that, and then it applies to all those physical ports. So if you make one change on that EtherChannel, it applies it to all of those Ethernet ports, those physical ports. You have to have the existing switch ports, so it uses the existing switch ports. Now, it's an advantage because you have to have them. It's also a disadvantage because if you don't have them, if your switch is full, you can't create that EtherChannel. It does load balancing between those connections. It'll even it out. It'll put, if you have 2 physical ports in your EtherChannel, it'll load balance between them. Talked about the aggregation. It's seen as one logical link. So STP, spanning tree protocol, won't block that. And then you have those multiple links again, those multiple physical links in that one logical link. If one of those physical links goes down, your ether channel will still stay up. That connection will still stay up and running. So you have that redundancy there. There are some restrictions here for ether channel. You can't mix the types of interfaces. Now, what do I mean by that? You can't mix a fast Ethernet connection with a gig connection. You can't combine those together. They have to either be all fast Ethernet, all gigabit, all 10 gig connections. If they're all the same types, all the same speed, think about, then you can combine those into one logical ether channel. You can take up to 8 physical ports in a physical channel, in an ether channel. 8 physical ports to make one ether channel. You can't do 9. So the maximum you can have is 8 in there. Each switch supports up to 6 ether channels. So that's each switch, each Cisco switch 2960 can only support up to 6 ether channels. But if you have 6 ether channels with 4 physical ports, 6 times 4 is 24. That's 24 ports. So if you have 48 ports, that's half of your switch right there to ether channels. If you like this episode on EtherChannel Operation and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Those physical member ports, they have to be consistent. Now, what do we mean by consistent? If one side of the connection is a trunk, the other side needs to be configured as a trunk. If one side has native VLAN configured native or VLAN 1, native VLAN 1 must be configured as the native VLAN on the far side. If those two native VLANs don't match, that ether channel, that logical ether channel, will not form. The logical port interface, that's what we're going to do the configuration on. You apply those configurations, and then it works to all of the physical ports themselves. There are a couple AutoNegotiation protocols that we could use to set these up for us. We could automatically have these ports, these ether channels, these logical ether channels, auto-negotiated. Now, there's two of them there. One is the Port Aggregation Protocol, and the other one is the Link Aggregation Control Protocol. They're very similar, very, very similar, and they use a dynamic negotiation process. We'll talk about each one of these here in a second. Now, you could go and set up what we call as a static or an unconditional ether channel without using any of these negotiation processes. You could just go in there and hard code it and say, okay, I want you to be this, and that's what you're going to be. No negotiation happens. Okay, first negotiation protocol, auto-negotiation protocol, is pronounced PAgP. I have a problem saying that. PAgP. It's written as capital P, capital A, lowercase g, capital P. This is a Cisco proprietary protocol. Now, is that a good thing or a bad thing? It's Cisco proprietary. If you are a Cisco shop, it's a great thing because it'll work on all Cisco devices and negotiate those connections. And when Cisco makes a Cisco proprietary protocol, they make sure it works. They give you all the bells and whistles in it. It's a good thing when you're in all Cisco shop. But as soon as you have non-Cisco stuff, then that's where the Cisco proprietary protocols do break down. Now, PAgP, it aids in the automatic creation of these Ethernet channels. You have to do a little configuration. We'll talk about that here on the next slide. But once you have that configured, they will go through and configure that ether channel for you. We do this through a communication between these ports and these switches where we send packets back and forth. And they go through negotiation processes. These packets are sent every 30 seconds. They make sure that your configuration is consistent, that it's correct. It manages the links. It can even go through additions and failures. So this auto negotiation, but it's mandatory here for PAgP here that all the ports have the same speed, meaning 100 megs, gig, 10 gigs, that it's the same duplex, full duplex, half duplex, and the same VLAN information. Native VLAN, VLAN's allowed, so you got to make sure that's all configured correctly. But then PAgP will take over for you. When we look at PAgP, there's 3 modes. There's the on, PAgP desirable, PAgP auto. On, it's just like flipping the switch. It says, okay, you are now a PAgP ether channel. You're on, no negotiation happens. Then we have the PAgP desirable, PAgP automatic. PAgP desirable is what we call active negotiation. It is there and it's trying to negotiate. It's a mover, it's a shaker. Hey, how are you doing? I want to make a connection with you. Let's do this. PAgP auto is what we call a passive negotiation. They're just going to sit there. They're going to wait. They're not going to actively find somebody to negotiate with. They're just going to sit there. But if somebody initiates that negotiation with them, then they will complete that negotiation process. So PAgP desirable is out there. It's the go-getter. It's, hey, I want to make a connection. How about you? Let's make that connection. PAgP auto is a person just sitting back there saying, okay, if somebody wants to negotiate with me, they have to start the process, but I will do that. So our 3 modes, once again, were on, PAgP desirable, and PAgP auto. Now, these modes have to be compatible with each other. Well, what do I mean by that? If we have on one side of our connection and we try to negotiate with that, no negotiation is going to happen because that on. No negotiation happens when you are in a mode of on. It's just, it's there and it's on. If it's a PAgP auto on one side, PAgP auto on the other side, the negotiation never happens because both sides are just sitting back there saying, okay, if somebody wants to start the negotiation process with me, I'll negotiate, but I'm not going to start it myself. So both sides are sitting back there like that, and it just doesn't happen. Of course, if you do use the no command with the ether channel, then the ether channel is disabled at that point. Here's a chart. We have 2 switches here, switch 1, switch 2. There's 2 physical connections with them. We have an ether channel set up right here. That's signified by the circle in the middle, circling, logically grouping those together. And then we got switch 1 and switch 2. Now, if the PAgP on switch 1 is set to on, and then it's switched to on switch 2, so both sides are set to on, yes, the ether channel will establish because both of them are on, say, okay, you're an ether channel. And that's it. Now, if switch 1 is set to on and the other side is set to one in negotiation, either desirable auto, nothing will happen because that one side, that's on, once again, is no negotiations happening. So the switch 2 needs somebody to negotiate. Switch 1 is not negotiating, so no ether channel is going to happen. If they're both set to desirable once again is, hey, I want to make a connection with you. And if both sides are like that, yeah, it's going to establish that connection. If one side is the desirable and one side's the auto, one side is, hey, I want to make the connection with you, and the other side's like, hey, I'll make the connection if somebody initiates it. Well, the other side's initiating it, so a desirable and auto, yeah, that's going to make it. And of course, if you flip that around, if it's auto and desirable, you flip that from side to side, that'll establish it. But if both sides are auto, once again, both sides are sitting there, hey, I'll create a ether channel connection. If somebody initiates that and both sides are like that, nothing's going to happen. So there's going to be no ether channel that will be established. The second negotiation protocol is LACP. I've heard some people call it LACP just because the other one's called PAgP. Some people call this LACP. The Link Aggregation Control Protocol. Now, this is part of IEEE. IEEE came up with this. IEEE is an international standards organization. It's an open standard. And what that means is anybody who wants to use this, they're free to use this. The Cisco proprietary, yeah, anybody can use it, but they're going to have to charge Cisco a licensing fee. And so a lot of vendors don't use PAgP because it's Cisco proprietary. On the other hand, all the other switches use LACP here. this LACP. Something to note though, Cisco is smart. Yes, we do have our own proprietary, but we also want to make sure that if a company has other switches, we can all play nicely together. So they also support the LACP. Now, it's very similar to the PAgP with the creation of those ether channels. We take physical ports, we group them into one logical port. And once again, that one logical port support, that's what STP sees, so it won't block all those other ports. Negotiation is automatic, and we do have the 3 modes, and they're almost identical to PAgP. We have on, LACP active, LACP passive. On, once again, is, hey, you're an ether channel, no negotiations happening. LACP active, the active negotiation is the one that's out there saying, hey, I want to create a ether channel with you. Let's go ahead and do this. Let's go ahead and do this. And they're actively looking for that. And then we have the LACP passive saying, once again, hey, I'll make a connection with you, but I'm not going to start it. You need to start it. So it's just sitting back, listening and listening. And finally somebody says, let's make a connection. They're like, okay, there we go. And we basically have the same chart here again for the settings. We got switch 1 on the left, switch 2 on the right. If they're on, if both sides are on, we'll make that connection. If one side's on and the other side's negotiating, the on side is not negotiating, so the negotiation side, nothing will happen. If they're both active, they're both saying, hey, I want to create a connection with you. I want to create, yeah, they will make that connection. If one is active, one is passive, we're going to make that connection. If we switch the sides on that, passive and active, that connection will be made. But if both of them are just sitting back saying, okay, if somebody starts it, I'll make that connection. Both sides are saying that, there's going to be no ether channel here that will get established. It was my pleasure to provide you with this wonderful episode on EtherChannel Operation. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.